It's not the prettiest plane on the block, but it's certainly one of the cleverest and the deadliest. This is the shape of the future. It's an aircraft whose very shape is designed to deceive enemy radar, and it's an aircraft that has to perform 3 duties. It's a fighter, it's a bomber, and it's a ground attack aircraft. This is the Joint Strike Fighter, the Lockheed Martin F-35LightningII.
Okay, back it out. Doors are closed, I'm going under for one. Clear.
The Lightning II comes in 3 versions: a conventional aircraft, a naval version to operate from aircraft carriers, and a short takeoff and vertical landing version, which can hover like the Harrier jump jet. The Harrier was a notoriously difficult plane to fly, and many pilots were killed just learning to fly it. The jump jet version of the JSF is said to be more user-friendly. Mike Scaff and the JSF simulator. This can reproduce the flight patterns of the jump jet version. The height, speed, missile state and position of hostile aircraft are projected on the screen like a head-up display. In a real-life situation, they would be projected onto the visor of a special helmet worn by the pilot.
Welcome to the F-35 cockpit. This is anthropometrically correct, and so it's the right size and shape and has all the controls of the real cockpit. This is Edwards Air Force Base out in front of us, and I thought I'd show you a short takeoff and then a vertical landing. Okay, I'm going to push this button, and that'll tell the airplane to open those lift fan doors and engage the lift fan and begin generating vertical lift. We're a little bit too heavy to hover, so I'm going to dump some fuel. The fuel is this magenta color, and you can see it dumping down. You can also see a new symbol that showed up, and it's a little airplane-looking symbol and some vectors pointing straight down and a number above the airplane. Right now, we're demanding 67% of available engine thrust, and those numbers, that's the angle compared to the vertical where the thrust vector is. So right now it's at 82 degrees and 90 is straight down. We've dumped the fuel. We're now light enough to hover. Notice that we're down to 82 knots, and so we're well below the stall speed for a fighter aircraft. But with the vertical lift, the airplane doesn't stall. From a pilot point of view, though, the airplane continues to fly like any other airplane. I can pull back on the stick, the airplane goes up. If I push forward, the airplane goes down. If I roll right, the airplane banks and turns. I'm going to click a button on the throttle, and it tells the airplane to decel into a stable hover. And you can see it says decel. Notice the nozzles went forward to 103 degrees to slow the airplane down, and it enters a stable hover. And so there's our airspeed at 0. Our radar altimeter is we're 52 feet above the ground. It takes 85% of the available engine thrust to hold the airplane up, and the thrust vectors are straight down at 90. Now the stick still controls up and down, and so if I pull back on the stick, notice the airplane goes up. And the rudder pedals are like torque pedals of a helicopter, and I can change the yaw of the airplane. If we put brand new pilots in here, we can teach them to fly short takeoff vertical landings in just a couple of minutes. Now, if we put helicopter pilots in here, they don't like it because it's too easy. They're used to having it very hard. When I want to convert, I push this button again. It unclutches that lift fan, closes the doors. We're back in a supersonic fighter. It's very agile and maneuverable. Now the head-down displays, the pilot can change the size of the windows by just touch. You can just barely see the airport right down there. You can see the 2 runways off in the distance. They are right there. And what I want to do is designate that point as a place that I want to take a picture, and I'll command synthetic aperture radar, and that causes the radar to go out and build a picture of the ground. And over in this picture, you can begin to see there are the 2 runways and there are some buildings down there. And now, every place I want to drop a bomb, I can move a cursor, almost like a joystick on a computer, and I designate, and a red triangle shows up, and that's a place that I'm telling the computer that we want to drop a bomb. And I can refine what I'm seeing down there, and I can slew to a building, I can zoom in again, and there you can really start to see the building that we're aiming toward. In the head-up display, there's aiming symbology, and the triangles down there are the places that I designated on this map for dropping bombs, and we can see them there. Here's the first release. And the second release. There are the two runways. There's the explosion of the first one. And then the second bomb should hit on the far side of the runway.
This is the short takeoff and vertical landing version of the Joint Strike Fighter Lightning II. It has a lift fan buried behind the cockpit. The engineers call it the hot tub. Like the Harrier, the F-35 has swiveling ducts which are pointed downwards when the plane is hovering. They're building the Lightning II at Fort Worth in Texas. It's so expensive to develop, $288 billion, that 9 other countries are involved, including the UK, Canada, Italy, Turkey, Denmark and Norway. Parts of it will be made all over the world, including Australia. Britain is one of the biggest partners and is building the aft fuselage and tail. The engines, either Pratt & Whitney or Rolls-Royce. Lockheed Martin have been testing the avionics of the Lightning II in this extraordinary-looking aircraft. It's called the Catbird, a 737 airliner which has had the nose section of the F-35 grafted onto the front of it. It contains the F-35's avionics. A section of the wing has also been attached to the nose and a long spine attached to the dorsal area.
We are building this cooperative avionics testbed for the F-35 program. And if you actually overlay an F-35 on top of the 737, the geometry from the tip of the nose to the leading edge of that small wing duplicates the whole front-end geometry of the F-35. Allows us to test the avionics in the same geometries that they are on the Lightning II themselves.
Nearly half the F-35 structure is built of lightweight carbon fiber. It's a stealth aircraft, and its very structure is designed to deceive enemy radar. You won't know it's been there until it's attacked you and left.